Hi everybody, how you doing? We are going to talk today about reciprocal functions. And in order to understand reciprocal functions, I think we have to understand the original function first and how it's graphed and what are its characteristics. And from there, then we can understand how, when we reciprocate that function, how that's going to behave, okay? So, do you know how to graph a line? Do you know the steps? So this is an ordinary line, very, very simple. It's in slope y-intercept form. You know that the y-intercept is easy to determine here because along the y-axis, x is 0. So if I put a 0 in there and I do that, because that term goes away, I'm left with that y-intercept, okay? So the y-intercept is -4. And then my slope is 2. Remember, slope is rise over run, so you can imagine a little invisible 1 under that. And we're going to go up 2 and over 1, up 2 and over 1, up 2 and over 1. And there's our line. A little wobbly, sorry about that. So this is the equation 2x minus 4. I'm just going to make a better drawing of that. There, that's a little bit better line. Okay, now what happens when we reciprocate this function? So we could say that what we want is y equals 1 over f of x, okay? Which means that what we're after is 1 over 2x minus 4. Now, we're not allowed to divide by 0, right? So that means that whatever the 0 of this is, and remember the 0, we're not talking about the y-intercept, we're talking about the x-intercept, okay? That's what a 0 is. Whatever the x-intercept of this is going to be the non-permissible value in the 1 over function, okay? So here, the x-intercept is 2, right? 2 comma 0. How do you solve for that? Well, you just make y 0, don't you? Okay, we're going to move the 4 over. We're going to divide out that 2, and x is 2, right? So sometimes you have to solve for it, sometimes it's pretty easy to tell. In some graphing situations, you know, you're going up 2 over 1, as we are in this case, and you're going to land on a grid intersection point if you're using graph paper. So, you know, whether you have to solve for it or not too difficult to find that x-intercept. Okay, now what we have to do is we have to consider what's going on here. So if somebody said to you, what is the non-permissible value of that 1 over function? What would you say? Well, you would find out what the 0 of the denominator is, right? Because the denominator is not allowed to equal 0. You can't divide by 0. So you might do this little bit of math here, and then you'd say x cannot equal 2, because it can't. So in the original function, which we've graphed, compared to the 1 over function, this is going to help us find this one, okay? When we look at this graph here, what we're looking for to start to graph this one is the x-intercept first of all. The x-intercept of the original function is the non-permissible value of the 1 over function. So look at this graph and make an asymptote right there, okay? Because that is the non-permissible value of this function. X must not go there. So what an asymptote is, there are kind of two different kinds of asymptotes in terms of what they mean. So in a vertical asymptote, it's a place where x must never ever go, okay? You can't ever divide by 0. So we have a sort of a hard line there that says x can't be on that line, okay? And what's going to happen is we're going to have a 2-part graph that we have to actually lift our pen or pencil in order to draw. A horizontal asymptote, by comparison, is one that this graph simply never goes to, okay? So for a vertical asymptote, it means x can't equal that number, and for a horizontal asymptote, it means y won't go to that number. When we're talking about domain and range, it comes to the same thing, you know. We say, for this one, we say x can't equal 2, and we could say y doesn't or won't equal 0, because there's a slight difference in meaning there. It's not that important to understand that difference, but it's good to know that there is a difference in those two asymptotes. Okay, at this level of math, you shouldn't see horizontal asymptotes that are crossed. We will talk about it though, probably in another video, not in this one. So, okay, there's also a third type of asymptote, which is an oblique one, a slanted one. You definitely won't see that. It used to be in the old Math 30 curriculum, it isn't anymore. You might see it in calculus, you should see it in calculus, the early calculus, but you will not see it in high school math, not anymore, not in Alberta anyway, okay? Okay, so where do we go from here? Well, we can look at a stepwise approach to doing this. So the first step in graphing the 1 over graph is to place your vertical asymptotes. Okay, there might be more than one. So when we're taking a quadratic and we're flipping it, because a quadratic has 2 zeros, the 1 over will have 2 non-permissible values and therefore it will have 2 vertical asymptotes. The second thing you're going to do is you're going to realize that where f of x was greater than 0, 1 over f of x will be greater than 0. And where f of x is less than 0, 1 over f of x will also be less than 0. Okay? So what do I mean by that? Well, let's think about what the y-intercept of this function is. This one here that we graphed, the original one, the line. The y-intercept is 4. Negative 4. Okay? So when we flip the y values, because that's what we're doing, right? This is y, f of x, and f of x is ending up in the denominator. So the concept of a reciprocal function is that your y values from your original will flip, okay? So this y value is negative 4, which means when I flip it, it's going to be negative 1 over 4. And indeed, when I make this 0 here, that's what I'll end up with, is negative 1 over 4, right? So negative 1 over 4 is my new y-intercept, okay? There is no x-intercept, okay? Because there is no way to make this function equal 0. It can't be done, okay? I would have to make y 0, and when I cross multiply, the denominator would go away completely there, so it just wouldn't work. Okay, then what we want to recognize is that any values of y equaling positive or negative 1 in f of x will be what we say is invariant. And that means unchanging, okay? Why? Because when we flip on this graph, when we take a value of positive 1 and flip it, and we take a value of negative 1 for y and we flip it, it doesn't change, okay? So the reciprocal of 1 is still 1, the reciprocal of negative 1 is still negative 1. So what we're going to do is we're going to mark those invariant points. Now I realize this graph is very indistinct, but whatever. Okay, now, what else? Now we look at, so these two would probably better be reversed, but it doesn't really matter, because now we're actually ready to draw the graph, okay? You could take some other points that you know. For example, maybe there's a y value up here, 4 or 5 or 6 or 7. You could take it and flip it, which would then be 1 over 4, 1 over 5, 1 over 6, etc. And the same here. But the upshot is this. Here's what your graph's going to look like. And it's going to be a bit wobbly, but I'll do my best. Okay, now the thing to know about graphs that have asymptotes is that the graph moves very, very, very quickly towards those asymptotes. Super, super fast, okay? And there's also an invisible asymptote here on the x-axis, which is kind of hard to draw because you can't see it because it's on another line. But there is an asymptote there as well, and that's that horizontal asymptote I talked about earlier. All of these functions, as I said before, when you start with a polynomial, and you flip it, it's got 1 in the denominator. You know, if you take 2x minus 4, and you say, well, what's in its denominator? It's 1. So its reciprocal is 1 over 2x minus 4. So your numerator, when you flip these functions, isn't going to have anything in it but 1, okay? Right, so for this one, the first thing we want to do is we want to graph the original function. We want to graph that quadratic. So you've got to know how to do these things. So make sure that if you're shaky on quadratics and how to graph them, or lines for that matter, go back and review that, okay? Because if you've got a good starting graph, it's going to be easier to graph the 1 over. Okay, so first thing we're going to do here is we're going to factor this. You've got to know what the zeros are, or else it isn't going to work, okay? Okay, so if factoring is a bit shaky for you, go back and review some of my old videos on factoring, okay? There's lots of them, and there's even playlists, so you can run through them and go through them in order. Okay, so is this all we need to graph it? Yeah, it's pretty good. We don't really need more. We have 3 points. We have our zeros, which are 2 and -1, and we have our y-intercept. The other thing we could do is we could get the vertex. The vertex is nice to have. It's not fabulous here to find it, but it's not hard. So remember, anything in front of x squared gets factored out. There's nothing, and then you do that, okay? Then you take that middle number, divided by 2, square the result, and that goes here, and then we just subtract that off there. And so what we end up with is x minus 1 over 2, all squared. This is minus 8 over 4 minus 1 over 4 is minus 9 over 4. Okay, I've also got lots of videos on completing the squares, so go back and look at those if you're looking at that and going, what did she just do? Go back and review some of the other videos. Okay, so now we've got 4 points. We've got our zeros, okay, so the zeros are 2 and -1, right? 2 from here, -1 from here. Our y-intercept is -2, and our vertex is 1 over 2 and -9 over 4, okay? Opposite sign, same sign, okay? So we've got a lot of information now to graph this. We also know that it opens up because a, the number in front of x squared, is a positive value. So we're going to go 1, 2, -1, y-intercept is -2, and the vertex is 1 over 2, okay, halfway between those x-intercepts, and -9 over 4, which is -2 1/4. So just below this point here, right about there is my vertex. Okay, so again, it's not essential to have the vertex, but it is nice to have it. Okay, so now how do we graph this one? So now we want y equals 1 over f of x, which is equal to 1 over, I'll put the factor form down, x minus 2x plus 1. Now, if you weren't doing any of this work and this is all you had to work with, this here, you'd say, okay, well, I should clarify that x can't equal 2 or -1, right? It would be clear from this, wouldn't it? And notice those are the zeros, right, of the original function. So always make sure that you understand how this works, and it'll make it a lot easier to understand how this works. Okay, so remember the steps from the previous question. Step 1 was to get those vertical asymptotes in place. Vertical asymptotes and horizontal asymptotes always drawn with a dotted line, okay? I know that there are teachers who, when you draw a graph that has vertical asymptotes, they will actually take marks off if you touch them, okay? So try to keep your pencil away from those asymptotes. Okay, so, and you know, labeling can help too. So x equals 2, x equals -1 for those asymptotes. And remember, vertical lines, even though it's not a solid line, it still has an equation. Vertical lines are always x equals equations. Horizontal lines are always y equals equations, okay? We have a horizontal asymptote here on the x-axis. Again, you can't really see it, but I'll just put it over top, okay? All of your horizontal asymptotes are going to be on the x-axis for these types of questions for now. If there's nothing in the numerator but a number, that's where they're going to be, okay? They're always going to be on 0. When you start to get degrees in here, when you start to get an x or an x squared in the numerator, then they move around, okay? Okay, so what else do we know? Well, we know that this value here gets reciprocated. So the y-intercept of our original function was -2. The y-intercept of our new function, of our 1 over, is -1/2. We also know that the vertex of our new function, so this is f of x, and this is 1 over f of x. Okay, so here these are NPVs, non-permissible values. This turns into -1/2, and this turns into 1 over 2, -4 over 9. Because it's y values that we're reciprocating, okay? So if you find your -9 over 4, which is right here, and it's -4 over 9. So that's, that's about -1/2. It's just above -1/2, so it's right about there. Now, remember that y values that are +1 or -1 on the original function will be invariant, okay? How many are we going to have here? Well, it looks like we're going to have 4. So right there and right there. It's hard on these graphs because they're kind of indistinct. And right there and right there. This one is on the outside of that asymptote. So, and then, again, from our list from before, remember that where the original function is greater than 0, the 1 over function will be greater than 0, and where the original function was less than 0, negative, the new function will also be negative. Because when you reciprocate a number, it doesn't change its sign, right? The reciprocal of -9 over 4 is -4 over 9. Sign doesn't change. The reciprocal of -2 is -1/2, yeah? And even here, the reciprocal of these numbers, of these zeros, we've got a value that is 2, 0 here. So if we reciprocate that 0, guess where it lands? In the denominator. That's why it becomes a non-permissible value, okay? Okay, so now all we have to do now is draw the graph. So you're going to hit those points that you've identified, your invariant points, okay, which are your plus or minus 1. So remember, invariant points, and they love to test you on these invariant points. You get more of them in grade 12 when you do transformations. You get a lot of questions, a lot of material on invariant points. It just means that when you change a function somehow, whether you reciprocate it or you move it or you reflect it in the x-axis or you reflect it over the line y equals x or whatever, all that means is that when you change it from one function to another, certain points will be invariant. In other words, both the original graph and the new graph will go through that same point, okay? And they like to test you on those, so make sure you're clear on invariant points. So for these ones, it's where y is equal to plus or minus 1. So we've got a few points. We've got our y-intercept, we've got our new vertex, so to speak. We've got our invariant points, and if you were graphing on graph paper and if you had some other values, or you could even take this and you could just find some values, any values that are in this domain, and then flip them so that you have new points or other points to make your graph even more accurate, okay? So remember that graphs that have asymptotes move very quickly towards them, and they just do a little bend there, like going around a corner. And here we've got this U-shaped thing, which is flatter than what you see at the bottom of a parabolic curve, okay? And then this one is right here. There. Okay, so that and that is your 1 over function. Okay, so I'll give you a minute to copy what's left there, or give you a second to pause it and copy it down if you need to. Okay, so to understand any function and any way to transform that function, it's a really good idea to have a really solid understanding of the original function. So these are the values of x and y on a simple line. The beginning, the basic starting point of lines, okay? Which is a 45-degree angle line through the origin like that, okay? Y equals x. So for every x we choose, y is the same thing, okay? So when x is 1, y is 1. When x is 2, y is 2. When x is 3, y is 3. When x is -1, y is -1. When x is -2, y is -2, and so on, okay? Now what happens when we reciprocate it? Well, you can see that we start getting into fractions like instantly, okay? So at -10, way over here, way out here somewhere, 3, 4, 5, 6, 7, 8, 9, 10, close enough. -10 is -1 over 10, right? So that value is so close to the x-axis at this scale that you can't actually see it. It's like practically touching it. It's not, but it practically is. At -2, we're at -1 over 2, so right about there. -1, we're at -1. Remember I said earlier that's one of those invariant points where y is equal to -1 and +1. In the 1 over scenario, they haven't changed, because when you flip 1 or -1, it's still positive or -1. Signs don't change, numbers don't change. Okay, so then for -1/2, we have -2. So here's -1/2, there's -2. Then for -1 over 4, which is right about there, we have -4 right there. You can see the shape taking shape, okay? At -1 over 10, we have -10, so that's way down here somewhere, okay? Really, really close to the y-axis, because it's -1 over 10 between, so here's 0, here's -1, so -1 over 10 is just a hair in, right? So, and that's -10 is its counterpart, its y value. Then 0, of course, is undefined. So that's the 0 of the original function. The 0 is 0. So that's where the vertical asymptote is going to be. The horizontal asymptote, as I said earlier, for these functions is always on the y-axis, or the x-axis for now. For 1 over 4, we have a value of 4, so right about maybe here. 1 over 2, we have a value of 2, and again you can see that shape taking shape. 1 is 1, it's unchanged. 2 is 1/2, and 10 is 1 over 10, really close to that x-axis. So that when you draw it, it looks something like this. Okay, so let's talk about some general rules about the shapes. So when you take a line, let's say x minus 2, you know, you've got your y-intercept here, you've got your x-intercept at 2, and there's your line, right? So when you do the 1 over, that's going to be your vertical asymptote, your horizontal asymptote. As long as your numerator doesn't contain any x's, you're going to have that y-axis, or the x-axis will be your horizontal asymptote. And then you just kind of do this, right? Okay, so that shape that you see there, let me draw it without the other line on there. So 1, 2, that's the asymptote, and it looks like this. Okay, so that shape is a standard shape for a line with a positive leading coefficient. One with a negative leading coefficient, like that one for example, -3 is its y-intercept, and it's got a slope of -1, which means it's falling, right? So there's our graph. That's the graph of the line. The 1 over graph, this one, now be careful here too, because I've always said that you shouldn't put negatives into denominators. Well, what if you factored out that negative? Here's what you have. Hopefully that makes sense, right? The 0 of this, what is it? Yeah, it's -3, isn't it? Right? Okay. So, because if you put -3 in here, you've got 0, don't you, in the denominator. So be careful with leading negatives, right? Like this negative x minus 3, what's its 0? Yeah? We would move the 3 over. Yeah? And then we just divide out that -1. So x equals -3, and there it is, okay? So be careful how you write these, be careful how you treat them, because here's what a lot of students would do, because I always tell people don't put negatives in denominators, they do that, they just pop that negative up into the numerator, and this is wrong, okay? This does not equal this, they're different, okay? So be careful there. Okay, so we have our, at -3, we have our asymptote, and our horizontal one. Now remember what I said before, so your invariant points at positive and -1 for y values, and where the original function was positive, the new function will also be positive because we're reciprocating y values, so we're not changing the sign of them, okay? And here where the y values are negative, the 1 over y values will be negative as well. So notice the different orientation of this graph compared to that one. Okay, sorry, a bit messy. But this one here, with a negative leading coefficient, looks like this. Right? Because a line with a leading negative starts out positive and then goes negative. And a function with a leading positive starts off negative and goes positive. So this one starts negative, goes positive. This one starts positive and goes negative. So it makes sense. But notice the shape is still the same, okay? Okay, and then there are two more shapes that you want to be familiar with. One is the standard parabola. So for this one, I'm only going to do this kind of quickly. You have your zeros at 2 and -3. You've got a y-intercept of -6. 1, 2, 3, 4, 5, 6. And your vertex is going to be right about here somewhere. So, looks like that. The 1 over function, we're going to have an asymptote here, an asymptote here, and then this here is going to look like this, and this will look like that. Okay, so I know, kind of messy, and they don't scoop up like that, right? They keep on going towards the x-axis, but it's a bit hard to draw on the board. And these two, these lines here and here, this upside down business, it's got a shape kind of like that, and it's always moving towards those asymptotes. If you put this on a calculator like a TI-83, what you're going to see is those lines, those graphs, they're going to move towards those asymptotes so fast that at a scale of 10 all the way around, it's going to look like the graph overlays those asymptotes. They're just going to glue together like instantly, okay, because they move towards them so quickly. So you have to open up the scale quite a bit, make it really small increments in order to see that they're actually still apart. Plus, a lot of calculators don't draw those vertical lines as dotted lines. They make them solid, and they don't draw the horizontal ones at all. So the calculators do a poor job of graphing reciprocal functions. or rational functions as they're sometimes called. Okay, and then the last one. So for this one, again, know what your original looks like, right? This one's a little weird. So there's your y-intercept of 4. This doesn't factor. It has no zeros. So this one won't have any asymptotes, right? So this looks something like that. Okay, it's just x squared moved up 4 units. And what do we do with this? Well, we do the same thing that we did with the other one. We take all of our y values and we reciprocate them. So this one you can't really use the list of steps from before. Everything that, all our values are already positive. So there's, where f of x is negative, 1 over f of x is negative, and positive equals positive. Doesn't apply here because everything's positive anyway, so it's going to stay positive. We also don't have any invariant points because we don't have y values that are equal to plus or minus 1. So take y values that you can identify and reciprocate them. So this is 4, so it's going to be 1 over 4, okay? Now, that number there, that 1 over 4 for y, that's the biggest y value that this graph is going to have. Because if this here is 5, and it is, right, because 1 over 1 up, right, for x squared, its reciprocal will be 1 over 5, which is smaller than 1 over 4, right? And if we go over here and over here, we're going to get, 1 over 8 or something like that, right? So even smaller. So what happens is, you get this graph. Now I'm going to run through this y-axis here just so I can draw it better. So you've got this graph that looks something like this. Right? It comes along the y-axis, it goes up. It's actually easier to do it that way. Okay, so there's 1 over 4, and there's your x-axis, and this is 1. That's what it looks like. And this here is y equals 1 over x squared plus 4. Think about it. It doesn't matter. First, why isn't there any asymptotes? Well, because the denominator can't ever equal 0. It doesn't matter what number x you put in here, it's never going to equal 0, that denominator, because you could pick the smallest or the biggest negative value that you want. What happens when you square it? Well, it's going to be positive. And then when you add 4, it's going to be even more positive. So you are not going to, this function will never equal 0, and the denominator will never equal 0. So you don't have any vertical asymptotes because there's no non-permissible values. And you've got this, what I like to call a natural asymptote on the x-axis, because the graph will never equal 0, okay, ever. It can't possibly. You could try solving for it if you want. Oops, plus. Right? So we want to solve for x here? Sure, let's try it. Cross multiplying, that's what we do. So this times this is 0. This times this is 1. Well, that doesn't work, does it? So when you're trying to solve for something and your variables go away, either they multiply away or they subtract off, and you end up with some goofy statement like 0 equals 1 or 3 equals negative 5, well then you know that it is not possible. And there are no solutions for what you're trying to find. Okay? Alright, so what we want to do here is we want to look at this graph and we want to figure out what is the function that made this graph. So clearly it's a reciprocal function, or it's a function with everything that's going on is going on in the denominator, okay? Now, if the vertex of my 1 over function is negative 1, negative 1 over 4, then the vertex of the original had to be negative 1, negative 4, right? Because we reciprocate y values. And then we've got, this is an x value, this is x equals 1, and this is x equals -3. So from that we know that we have a value that we have in our denominator. We have x minus 1 and x plus 3 because these are values, because these values of -3 and 1, those are non-permissible, and so therefore they must have been in the denominator of my function, right? So, you know, we could say here x cannot equal -3 and 1, right? And there is the proof. Those are the vertical asymptotes that show us that. Okay, so now let's have a look at this vertex, so to speak. Well, the original would have been, at least we're assuming at this point, x minus 1 times x plus 3. What's the vertex of that function? Is it this? Let's find out. So first of all, let's put this into standard form. So x squared plus 3x minus x minus 3, and then x squared plus 2x minus 3. Okay? And now we're going to complete the square, and that'll give us our vertex, right? See, I told you this was useful. So it's always good to know how to do these basic things before you dive into the more complex way of treating these functions. So x squared plus 2x plus the magic number minus 3. Magic number is 1. So that 1 that gets added here gets subtracted there. And so we end up with x plus 1 all squared minus 4. See that? So the vertex here is -1, -4, just as we thought. And the vertex of the 1 over function, we know will be -1, -1 over 4. So that's how you build them in reverse, okay? Okay, so that's it for today. Thanks for watching. If you have any questions about anything, please put them in the comments of the video, and I will answer as quickly as I can. And if you put special requests in the comments for any particular topic or a specific question, please put those in the comments as well, and I'll get to them as quick as I can. Okay? Thanks. See you next time.